Alright, and just subscribe to the Tone channel, Tone Academy or the T1 channel, and just relax and follow the sequence of these chemistry classes. I think you will be writing with confidence the aptitude exams, that is nothing but your NEET or JEE mains or whatever, any other pre-engineering tests or pre-medical tests. Yes, the next lecturing is the Schrodinger's wave equation, and welcome aboard all the students who are pursuing science, right? You can just relax, right? And today's lecture, as we are following the sequence, we will be discussing about the Schrodinger's wave equation. Right? Now, what is this equation? We will get into that details a little later, but I wanted to draw your attention on, from the beginning, starting from radiation, right? People were telling that the radiation was having dual nature. So it behaves as a wave and a particle. And then you have yesterday Heisenberg's uncertainty principle, where basically, he has drawn the curtains for what? Exactness or finding exactness or the position of an electron. He has drawn those curtains. Then we introduce actually when someone has drawn the curtains on the certainty of an electron. So the question or the speaking with regard to certainty with respect to, the subatomic particles like electrons is completely ruled out. It's completely ruled out. So what people used to do after Heisenberg's uncertainty principle is they used to talk in probability terms. Like, let me remind you, in the school, your teachers were telling the definition of an orbit or an orbital. They used to say the probability of finding an electron is 99.99%. So they never spoke in what? Certainty terms. You must understand that's because of the Heisenberg's effect, where he was actually targeting Bohr and he was telling it's not difficult to determine the position and velocity of an electron, but rather it is impossible when you do it at the same time. So after Heisenberg has stopped people for speaking in certain terms with regard to what? The finding the position and velocity of an electron, then people used to talk in probability terms. And let me tell you that the probability concept was first introduced by the Schrodinger, and let me tell you, he is an Austrian. He has nothing to do with, physics or chemistry, but I think he is an Austrian and he's a mathematician rather. So what he has done basically is, whether it is matter, whether it is radiation or matter, right, both, he has considered all the theories which are proposed. He has not discounted anyone. Suppose if someone is telling you radiation is a particle, of course, yes, it is a particle because we have the effects of that. And if someone is telling radiation is a wave, yeah, of course, yes, because radiation must be a wave because we were able to find out or explain convincingly the properties of what? Light or radiation. Similarly, when you come to de Broglie, in the last lecture, I was telling you in the de Broglie's equation, you have seen that the matter also is associated with a wave. And there is no confusion when someone is telling me I walk like a wave. You must understand. Of course, yes. When I walk like a wave, my wavelength should be put in my hand, right? So you can calculate, my wavelength and put it in my hand, and then you can apply for electron also, where electron behaves as a wave. And electron's wavelength is in the closed dimensions of X-rays. So it is so convincing that electron is a wave and photon is a wave, and all other matters are associated with what? Wave. So if such beautiful explanations are given where every particle, including the radiation, is associated with a wave, then I think there is no point in discounting any theory. All theories are good. Well, what I will do, me means it is Schrodinger. What he is trying to do, what he is basically trying to do here is he wanted to consider all the theories, both the wave theories as well as what? The particle theories, and mix it up and propose an equation and then finally tell us what exactly is that. Now observe carefully here, observe what is his basic equation is. I write the equation for you. Now there are so many, medical students who don't have the background of mathematics. That doesn't matter because we are not solving any equations over here. Only the gist of the Schrodinger's wave equation we would like to tell you, but otherwise I think you can leave all those things. Observe carefully, I'll make it simple for you. Understand. So what are we basically doing here, just to have a recap of what I'm telling you here. Understand, this is basically a probability concept. Now, when someone is introducing a probability concept, that clearly indicates that, they have, you're speaking in certainty terms with respect to electron. The electron is there itself. It is 100% sure. There itself it is revolving, and all these things are completely ruled out. So now, after Heisenberg's uncertainty principle, I think people are speaking in uncertainty terms. That means that the probability terms you must understand, right? So it's probability terms, and it was first introduced by the Schrodinger. And what is this equation? I would like to write the equation first for you. Well, I'm writing the equation and I draw the attention of everyone, right? I'm writing the Schrodinger's wave equation for you. Watch and look into this. This is the Schrodinger's equation. It says dou square psi by dou x square. Don't get threatened. The people who are pursuing medicine, pre-medical tests, or writing NEET or any other pre-medical test, don't get threatened, because we have nothing to do with the equation. We have absolutely nothing to do with the equation. The only thing is that let's note the gist of it. What is this issue, right? So understand here, the equation says dou square psi by dou x square, right? And I write dou square psi by dou y square, and I write it again, please. Watch carefully. Dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into e minus v into psi equal to 0. As I told you, don't get threatened. Absolutely don't get threatened, because we are not solving this, equation, especially the non-math students. You don't get threatened over here. Watch carefully. I'll make it absolutely simple to you. Now, this is the Schrodinger's wave equation. Now, what is the Schrodinger equation? I would like to read it. Dou square psi by dou x square, dou square psi by dou y square, dou square psi by dou z square, plus 8 pi square m by h square into e minus v into psi, right? Now I'm addressing the non-math students who don't know mathematics. For them, if you ask me what is this, well, I would like to call this is basically a differential equation. This is basically a differential equation of second order. Mind you, this is a differential equation of second order. Now, if there are non-math students, don't get threatened. If you ask me what is this differential equation of second order, forget about differential equation. Just consider it as an equation, that's all. It is basically an equation. An equation will be having an LHS and an RHS. And this is the LHS, that is the RHS. And you just consider it to be basically an equation, that's all. Simple as that. Right? And for the math students, I think I can address to them, it's nothing but differential equation of second order. Well, if that is the case, every equation will have a solution. Every equation must have a solution. For example, if I take, for all the non-math students, you can actually look here, and if you see, I have an equation x plus y. If I say x plus y is 3, I consider this to be an equation because you have an LHS term and you have the RHS term. And since it is an equation, every equation must have a solution. So if I can solve this equation, then I can simply say x is 1 and y is 2 such that x plus y is 3. You must understand that. Otherwise, I have a solution for x is 0 and y is 3 such that x plus y is what? 3. You must understand. So, even though it looks to be threatening, this equation for the non-math students, you must understand and look it as an equation, that's all. You just think it's an equation. And also remember that every equation has a solution. As this equation has a solution, after all, this equation will also have a solution, right? If this equation has a solution, now mind you, in this equation, you are finding the values of x and y. Now, if you say, if this is an equation, the above equation will have a solution. I would like to write. The above equation has a solution, and let me tell you solution for what? Now here in this equation you are finding solutions for what? X and y. You are basically finding the solutions for x and y, right? Now similarly, if this is an equation, this equation also has a solution. also has a solution. So the above equation has a solution for what? For what? For psi, for psi, for psi, for psi. So basically, we are solving this equation to find out the value of psi. You must understand that. We are basically finding out the values of psi. As you have an equation there, you have found out the solutions of x and y. I am telling you that this equation will also have a solution, and we have to determine the solution for psi. For math students, I think since it is a differential equation, you know how to solve it, the variable separable method or the rational method, and all other methods, actually you can use it to solve this differential equation. Whereas for the non-math students, you just understand that this is an equation and every equation will have a solution, and here also we will have a solution, and we are finding the solution for psi. You must understand that. Psi. Now what is this psi? Let us have an idea of what exactly is psi according to Schrodinger. Well, let me tell you, and I would like to highlight here, and I draw the attention of everyone, watch carefully here. What is psi? What is psi? And psi is basically nothing but the amplitude. It's basically nothing but the amplitude of the electron wave. Amplitude of the electron wave. Amplitude is the maximum displacement from the mean position. I would like to draw the diagram also. If you are confused with the amplitude, then it's basically nothing but orbital. That's all, simple. It's nothing but the orbital. You must understand that. Orbital and amplitude of the wave is nothing but the same, or otherwise we call this to be a wave function. We call this to be a wave function. So whichever way you wanted to treat it, this psi or understand, and these are all synonymous. Wave function or orbital or amplitude of the electron wave, anything you can actually take it. You must understand this. This is basically what he is doing. Schrodinger is taking basically a wave mechanical model. When I say wave, understand what is wave. It will have dimensions. That's nothing but wavelength and frequency. That is the language of a wave. Now coming to mechanical model, that means you are producing some kinetic energy. Now if you actually see in this equation, this is total energy minus the V, which is potential energy, and the difference of this is kinetic energy. So if you see, I can actually pledge for myself that when I open textbook and in any equation, if I find kinetic energy, I consider it to be a mechanical motion, and with respect to this context, that means that the electron is also behaving as a particle. So what I'm trying to accept as a Schrodinger is basically, I am not discounting the wave theory nor discounting the mechanical theory, that is the particle theory. I consider both and induce both, keep it together and make an equation that's nothing but the Schrodinger's wave equation. And look into this. This is the Schrodinger's wave equation, and this is a differential equation of second order, and all the math students can actually solve this. And then if you're a non-math student, just view it as an equation because it has an LHS and an RHS, and then every equation will be having a solution, and we are finding the solution for psi. We are finding the solution for psi. And what is psi? Basically is amplitude of the wave. Now, if you actually see, this is what is the electron wave. This is what is the electron wave. This is electron wave. Mind you, earlier we don't know. We just know that the electron is a particle, because people were telling when you are shooting the electrons from the gun in the Thomson experiment, right, the electron beam is actually rotating the paddle wheel. When someone is rotating the paddle wheel, it's almost like the electrons pushing the paddle wheel and they are rotating it, right? When they rotate, it's a mechanical motion, and we are convinced that electron is a particle. That's fine. But later, as I told you in yesterday's theory, de Broglie has introduced, and he extrapolated, all matter is basically associated with a wave. From then onwards, when I'm sleeping, I'm getting dreams of electrons to be a wave, and this is how they are looking at. Earlier you were dreaming something like that, it's a pepper seed or a mustard seed, that's how the electron was looking for you. But let me tell you, this is how the electron wave is, right? This is what is the amplitude, the maximum displacement from the mean position, and this is what I call psi. That is the psi in this equation. That is the psi in this equation, right? And let me tell you, you have a psi down the mean position. So what I will do, this is psi positive and this is psi negative. It's complex conjugate. I can simply say it is the complex conjugate of the psi. You must understand psi plus and psi minus. So when I say amplitude, I need to consider both. And look into this, this psi plus and psi minus are meeting at a point where the point is 0. Now what is this psi basically? Say psi is nothing but, that's where the displace, this is an electron wave. So I think you will find the probability of finding the electron is a maximum at what? Psi plus and what? Psi minus, because these are the displacements maximum. You will find it very less over here. You will find it very less over here, less over here. This will give you the maximum probability of finding the electron. And we also have the other one, it's complex conjugate. This is the maximum displacement of the electron wave, you must understand. It's almost like if you, Aishwarya Rai in Mumbai, where the probability of finding her is more in the beauty parlor rather than you have very less probability of finding her in a football ground. You must understand, it's a common sense now. If you wanted to search her in Mumbai, better search her in the best beauty parlors in Mumbai, not in the football grounds or the cricket grounds, because the probability of her visiting these grounds is absolutely 0. And such a probability is where this and this basically meet here, and this is called the nodal point. You must understand that, where the probability of finding the electron is absolutely 0. So understand the psi. The psi is basically the amplitude. This is the amplitude which I'm speaking of. This is the amplitude I'm speaking of, which is nothing but the psi plus, and its complex conjugate. And basically, if I can write it properly, it is complex conjugate. It's complex conjugate, you must understand, which is psi minus. Both we need to consider. Both we need to consider. Now, what is very strange here? What is very strange, I'm telling you. The strange thing is, you must understand that electron is a wave, right? And I don't agree with someone basically drawing like this for electron, basically drawing like this for electron with a neat boundary. Neat boundary. It doesn't happen like that at all. Electron is a wave. And wave has a diffusing property. It's relaxing like this. It's diffusing property. And also let me tell you that it has an irregular boundary. It basically has an irregular boundary, mind you that. It's not like so fine, right. It's like a cloud. It's like a cloud. I think you have seen clouds. They are diffusing always. They're diffusing always, and then they have an irregular boundary. Like prima facie understanding, they will print that in that fashion in your books, where the shells you have round, excellent boundary. No, absolutely not. You have to come out of that perception and understand that electron is a wave, and a wave has a diffusing property and of course has an irregular boundary. That's how the electron must be dreamt of. So if that is the case, if someone is asking me, draw an electron wave, this is how I draw. This is the psi and this is the psi, that's psi plus, and this is psi minus, it's complex conjugate. So what I'm doing basically is Schrodinger's wave equation, in which he has used the probability concept, because that's the effect of Heisenberg's uncertainty principle. He has warned people, don't speak in certain terms with respect to electron, because it's so dynamic. After that, people are using the probability concept. And what Schrodinger has done is he has taken both the wave concept as well as the mechanical concept, and this is nothing but the wave mechanical model, and he has given an equation, and every equation has a solution, and I am finding the solution for psi, and I am explaining what is psi for you. Psi is nothing but the maximum displacement from the mean position. You have psi positive and psi negative, and both we need to consider, and you know very well that the modulus of the complex number is basically nothing but positive, and that is the square of it. And let us see what exactly is that. Now let's not get deviated, because I promised that every equation will have a solution. Every equation will have a solution. We have still not found out the solution for psi. Let us find out the solution for psi. I am not doing any calculations, but I will tell you what are the solutions of psi, because they have already been done. You need not do anything. Watch carefully here. Now the solution for psi, and as I explained what exactly is psi, then watch carefully here. Watch carefully here. If this is the case, then the solution for Schrodinger of psi, the solution of psi in the Schrodinger's wave equation, SWE, the Schrodinger's wave equation, after solving, you need not do it, it is solved. If the mathematics students wanted to solve it off for again, I think you are welcome to do that. For non-math students, it's immaterial, irrelevant to you. Just, I have solved it as I have solved the simple equation. I have solved the Schrodinger's wave equation. There we are finding x and y. Here we are finding psi. And I draw the attention because this is beautiful. This is absolutely beautiful, beautiful rather. It's absolutely beautiful, you must understand, right? What is so beautiful here? When I'm solving the psi, I code this in a box because might be a question in JEE. This might be a question in JEE or whatever exam you're writing. Well, this has been asked a number of times. So I would like to tell you the solution for psi. The solution for psi gives, and I want your attention what I'm writing. You need not solve it, it has been solved. And the solution for psi gives, it is giving you, watch what I'm writing here. It's basically giving quantum numbers. It's basically giving you quantum numbers. And what are quantum numbers? Quantum numbers, and I'm writing it here for you, it is giving basically a solution of psi is basically giving you quantum numbers. Quantum numbers, and what are the quantum numbers? It is n, that's your principal quantum number. And this is the principal quantum number introduced by Bohr, where you have proposed non-radiating path or the shell or the orbit or the stationary orbit. This was proposed by what? Bohr. You must understand. And then you have L, which is another quantum number. This is azimuthal quantum number. Azimuthal quantum number. And this is proposed by Sommerfeld. This is actually proposed by what? Sommerfeld, you must understand. Right? And then you have the other quantum number, M, which is nothing but the magnetic quantum number, and this is proposed by Landé. You must understand. So it's easy to understand, don't get threatened. If you actually recollect, we were telling what are you doing in atomic structure? Well, basically I'm finding out the pinpointing the address of the electron. It's as simple as that. Well, how do you do that? Some fellow proposes shell, that's nothing but your Mumbai. It's almost like you are writing a letter to your friend in Mumbai, right? How do you do it? First you get down in Mumbai, then take an auto, go to an area, then go to the building, then go to the door number. So in moving from Mumbai to the door number, the probability of finding a friend increases. It is also almost similar what's happening in the atomic structure. Look into this. Someone has proposed Mumbai, then someone has proposed the area, let us say Andheri, and then someone has proposed the building. That's nothing but the money, so ABC building you can say, then take the lift and get into the house. And then on moving from the principal quantum number to the magnetic quantum number, the probability of finding the electron is increasing, right? I'll come to that, but understand that when you solve for psi in the Schrodinger's wave equation, it gives quantum numbers, that is n, l and m. And I want to draw your attention, if anyone is missing out on that, I draw the attention of you. Watch carefully here. N, L and M and I write 2 times, and so big I'm writing not, and I write it 3 times for you. Not the other quantum number, because we have 4 quantum numbers. Principal quantum number, magnetic quantum number, and then you have your azimuthal quantum number, and we have spin quantum number, right? So what I'm telling is, if you solve for psi, it gives you n, it gives you l, it gives you m, and not. I'm underlining this. And not, and not what? The spin quantum number. And not the spin quantum number. You must understand that. Out of the 4 quantum numbers, the solution of psi is basically not giving you the spin quantum number. And hence the question, if I can write the question for you, it is like this. Which of the following is not a solution for psi in Schrodinger's wave equation? And of course the answer is what? The spin quantum number. The spin quantum number. Yeah, and all others are the solutions except for the spin. Well, people wanted to know. People wanted to know why all the three are the solutions and why not spin. Well, understand this. The better way to understand is the principal quantum number is nothing but an area. It's an area. It represents an area in an atom. And because it is a shell, what is principal quantum number? It's a designation given to your principal quantum number is a designation given to your orbit or the shell or non-radiating path or the stationary orbit. Now what are these? These are shell means it represents a particular area inside the atom, right? A larger area rather. I think you can compare this with Mumbai, because if you're writing your address to your friend, first you need to get in Mumbai, not Chennai or in Hyderabad. So that's Mumbai is a such bigger area. That's nothing but the principal quantum number, right? And then you need to get into Andheri, a smaller area. Then you need to get into the building. So you must understand this, all the three representing spaces inside the atoms or areas inside the atoms, right, where the electron resides. And spin quantum number is something to do with the spin, and because the electron is basically spinning on its own axis and then revolving around the nucleus. You must understand that. It's basically spinning around its own axis and then spinning around the nucleus. You must understand that. Right? So, I write this question for you. Which of the following is not a solution of Schrodinger's wave equation? Well, the answer would be spin quantum number. It's basically spin quantum number, and that's a question. In the options, he will give you N, L, M, and the answer is what? S. You must understand. Right? So, what I mean, I would like to write and quote here, watch carefully, remember, N, L, M. They have in common, that's nothing but the areas or spaces inside the atom. And now you have spin is not representing what? It's not representing space. So S is basically not a solution of Schrodinger's wave equation. You must understand that, right? Well, I would like to give the highlights of what we are discussing in the Schrodinger's wave equation. Look into this. Now, the Schrodinger, he's basically an Austrian. Not Australian, he's an Austrian, right? He's a mathematician. And this theory basically considers wave theory, as well as it considers the mechanical model. That's nothing but the particle. Right? It's considering, not discounting any theory. Both it considers the wave theory as well as what? The particle theory. Both it will be considering. And and then he frames his equation. And the equation is basically solved for psi. And you're getting, and the solutions are basically nothing but the quantum numbers. So it is N, L, and M, and not what? S. Now you must understand, when I move from L, and M, right, because S is not a solution, when I move from N to M, the probability of finding electron increases. You must understand that. The probability of finding the electron increases. Now, N, L, and M, all the three have values. They are values, and they are the solutions of psi. And remember, I was telling you, if I consider this to be an electron wave, this is psi positive, and this is the amplitude which is psi negative. Well, I want to consider both, so psi positive, right, into psi negative. When I give the multiplication of these two complex and its complex conjugate, then I get psi square. Mind you that. Then I'm getting psi square. This psi square gives maximum probability of finding the electron. You must understand. So if someone is interested in finding the pinpointing the address of the electron, the final destination would be Schrodinger. Because if you ask Bohr, where is the electron, except for shell, he doesn't know anything, except for NRP, except for stationary orbit, except for Mumbai. He can't pinpoint what? The address of the electron. You need to get to the closer area. Then you need to get to L, then you need to get to M. And on moving from N to M, the probability of finding the electrons, in between if you get some values for each and everything, the probability of finding the electron is nothing but the psi square, which is basically giving nothing but the complex into its complex conjugate, which is psi square, which is giving you the maximum probability of finding the electron. You must understand that. Right? Now let me throw some light on what is this N, L and M. Right? Let us see that. Understand here. If this is the case, let me check. Let me check what is N, what is L, what is M. First of all, why this probability concept? Why it is basically impossible to determine the exact position of an electron and the exact velocity of the electron both together at the same time. Why it is actually impossible. Now understand this. Now assume. Well, why? I would like to quote this for you. Why it is impossible to determine exact position and velocity of electron. Because it is determining both together is impossible. That's why Schrodinger has introduced the probability concept. But why is it impossible? Now, for example, if I wanted to pinpoint the address of the electron, suppose this is the area. This is the area, right? Which, you can say that is the area proposed by Bohr, right? Let us say that this is the shell. This is the shell. And here is an electron, assume. And I wanted to find the position of the electron. That means distance from the nucleus to this particular electron if I wanted to find an attempt. If you attempt, then how do you do that? Because you can't have a scale, cut it off the atom with some cutter in the kitchen and then open it out, take a scale and from the nucleus to this electron, all these seem to be practically impossible. Impossible. First of all, atom is invisible to the naked eye. So now understand that how do you do that? How do you do that? Now the only way to do is pass the radiation, take the photograph of it. It's as simple as that. Only radiation is the only available tool to check out the position of the electron. So what I'm doing, normally how to get the photograph of an electron? How do you get your photograph when you go to a photo studio? The light is put onto me and then reflected back to the camera where I get my photograph. So this light is coming onto me, which is reflecting from my face, taking my face dimensions, getting back to the camera, and you get your image. That's how it is done. So similarly, if someone is wanting to pinpoint the address of the electron, then he's taking the camera and is just focusing on this electron. Then some light is put onto the electron. You must understand that. Now remember few things about electron. First of all, it's dynamic. It's dynamic. It's not only dynamic, it's extremely dynamic. Because if you see the average velocity of the electron, it is 2.18 into 10 power 8 centimeters per second. That much is the velocity of the electron. That is almost equal to 200 million centimeters per second approximately. So that is extremely dynamic. So it will be foolish on the part of the cameraman that he takes the camera and just try to put some light on the electron. Well, first of all, if this is the electron, it's so dynamic, he's trying to put the light on this electron. So that particular, the electron, and the light is actually striking the electron, which is already dynamic, and it's moving away. So if it moves away, it moves on to here. It moves here. Then again the cameraman is after that and posing some light on that, and then it's moving on to here. And then he's moving after it, and it goes on like this. So basically understand that this is how it is running off. You must understand. You must understand this. Right? This is how it is going off. It is so dynamic. It is foolish on the part of the cameraman going out the camera and putting some light on what? The electron. It is so dynamic it is. It is absolutely dynamic. Look into the velocity. Right? And the light which he is actually putting it must have the dimensions of the electron. You can't go, if you put greater than the dimensions of the electron, then the electron will be kicked out of that particular area. So you are actually within the dimensions of the electron, and the light energy must be carefully adjusted such that the electron is not kicked out from the atom. So the positive point with the cameraman is basically when someone wanted to take the photograph of an electron, you must understand that when he's kicking the electron over here through some light, it's moving off, moving off, moving off, it's dynamic. But the positive point with the consolation for you and me and the cameraman is, please understand that the electron is basically not moving out from a particular orbit, particular area. Because you are putting light or striking the light which is striking the electron is within the dimensions of the electron, so it's not knocking away the electron. So the electron is moving away in an area, that's all, that's how it is moving. That's why when you open textbooks, when you actually open textbook, you will see the s orbital being there. If I say this is how the s orbital looks like, that's how the s orbital looks like. Now someone is telling me, here is a nucleus, and this is the exact position of the electron. This is the exact position of electron as proposed by Bohr, is absolute nonsense. It's absolute nonsense. How can you actually determine the position? What you're doing is, when you strike the electron with some light within the dimensions of the electron, it is inducing a velocity into it. It's inducing some more velocity into it. And then if you run after the electron with a camera, then again you strike that, it is moving with some more velocity. So it is so dynamic initially, and you're striking the electron, and the electron is moving away like this, like this, like this. So if someone is telling that I have found the position of the electron, is absolute nonsense. This is ridiculous, because that's why you can actually find it out like this, like this, like this. That's why when you open your s orbital, it is actually drawn like this with some shades. You must understand that. So the Bohr's theories seem to be, well, not convincing at all, except for if you ask him, where is your friend? I think you can simply say he is in Mumbai, that's all. But Mumbai is so vast, you can't get down in an airport and shout for your friend, he comes on to you. No, absolutely not. So that's not convincing for me. So understand that determining both the position as well as the velocity at the same time. Because if you wanted to find this position with some light, it's going away with some velocity. It is inducing a change in velocity. So the more you are trying to be accurate with respect to position, it is inducing a change in velocity. So someone claiming that both I have done accurately at the same time seem to be absolute nonsense. You must understand that. So because of all this, I think we have actually proposing the probability concept through the Schrodinger's wave equation. And what he has done, well, he has taken into account. He has taken into account the electron being a wave, and he has taken into account the electron being a particle. Both he has mixed together, and that's why we call it to be wave mechanical model. And in the Schrodinger's wave equation, we have tried to find psi, and the psi square will give you the maximum probability. Look into this word probability. Probability. All this is coming because of these issues. Because of these issues. No one is telling now, from now onward, the language has changed completely. I have seen the electron. It is there 100%. I am sure about it. It is absolute nonsense. Such language with respect to any subatomic particle is absolute nonsense. Don't use it. Right? So use it in probability. The probability of finding the electron in a particular area is fine. That is nothing but the orbital. You must understand that. Right? So on moving from n to m, the probability of finding the electron increases. You must understand, in psi square, actually you can knock the door and get into even the apartment to check out where he or she, your friend, is available in that room. You must understand such accurately, the people have pinpointed the address of the electron. If not 100%, I think they have done it with 99.99% probability. So the combination of Bohr, combination of Sommerfeld, combination of Landé, and the psi square proposed by what? Schrodinger, all together, put together, will actually give you, and we can pinpoint the address of the electron. You must understand. Now let us focus on what is this N, L and M for you. Watch carefully here. Watch, and I draw the attention of everyone. Watch carefully. What are these N, L and M values? Watch carefully. What are N, L and M? Mind you, N is nothing but the shell. Well, L is called the subshell and M is called the orbital. So, shell is also orbit. Now, people will be casual while speaking. You cannot be casual in substituting orbital with orbit. Both are completely different. You must understand. So people cannot be casual in calling orbit and orbital to be same. It's orbital, it's orbit. What is the difference? No, there is difference, right? Because the shell is designated by N, and this is the principal quantum number. It's designated by N, and L is the azimuthal quantum number, and it's designated by L. And M is, of course, what? The magnetic quantum number, and designated by M. Well, one thing is sure. In Mumbai, the Andheri is in Mumbai. The Manish Park, your friend's ABC building, is also in Mumbai. So it's not there in other city. All belong as a subset to what? Mumbai. Similarly, even though this is a shell, this is a larger area, the L values must be belonging to N, and the M values must belong to L, and L in further will be belonging to what? N. So these are not independent designates, but rather each value depends on the other. You must understand that. Right. Now what we will do, we'll focus something on L, 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 M, and let me see why I am telling you that you cannot be casual in substituting one word for the other. Right? This is something like in a larger area, this is a subset of that larger area, that's further smaller area, but all these two areas belong to what? The shell. You must understand that. So if I'm finding the value of M, it will be depending on L, and L depends on M. So basically M is controlling all these, the other quantum numbers. They are not independent values. They are relative values, and each fellow depends on the other. For example, if I say N value is 1, right? If N value is 1, and then L values will vary from 0 to N minus 1. You must understand that. So you can actually see the L value depends on N. L value basically depends on N. You must understand that, right? And if I can find M values are minus L to plus L, including 0. Including 0, you must understand that, right? And the spin values, even though it's not a solution, it can be plus half or what? Minus half. So basically you have 4 quantum numbers. All the 3 are giving the probability of the electron, and that's not a solution of psi. That's not a solution of psi because it just represents spin. Positive half and a negative half. You must understand that, right? But I'm still writing it because in total the quantum numbers. But that's not a solution for psi. You must understand that, right? And you can see that L value depends on N, and M value depends on L, and all this depends on N. So I can simply say that L and M are basically sub-areas of what? The shell itself. You must understand. So what is this? Suppose if I substitute N value is equal to 1, then L values will be 0 to 1 minus 1. That's nothing but 0 to 0. That means you are getting only 0, which is only one value. Don't go into 0, the value. How many number of values you are getting, that's important. Well, I draw the attention, please. I draw the attention now. Don't get into what the value is. What the value is. You check out how many number of values you are getting. You must understand that. I got only one value, so I write it as one value. So for a given value of N is equal to 1, I got an L value which is only one value. You must understand. And if I go for M value will depend on minus L to plus L including 0. So that will be M is 0 here. So minus 0, 0 and plus 0. That is again you are getting one value, only one value, only one value. You must understand that. So if you are getting N value is equal to 1, L value is only 1, and then M value is also 1, you must understand. Don't get into the 0. 0 is insignificant for you. How many number of values you are getting? How many number of values? So, for a given value of N1, that is the first shell, the number of values for L is only one value. Similarly, M is also having one value. You must understand. You must not, don't get into what is this 0, what is that 0, and what is the other values. No. It is only the only thing matters in quantum mechanics is the number. It is a number. So what do you mean by this? This absolute meaning is, I would like to say, n is equal to 1 means it is the first shell. It is first shell proposed by Bohr. Then in the first shell, do you have any other divisions? Is the issue. And for that, check L value. L is the subshell. So the number of values are only 1. So for a given value of n first shell, number of values of L is only 1. That is 0. That's 0 as insignificant. But the number of values is only 1. That means it implies that you have one subshell. One subshell only in what? A shell. Right? And then coming to M, and for a given value of n, number of values of M is also 1. It implies only no further divisions in what? The subshell. You must understand this. So it's a number of values which are mattering. So if I put n is equal to 1, the number of divisions further is only 1 because I got only one value. It's not 0 values. 0 is one value. One value. Don't get into the number. Don't get into and investigate that 0. No. For a given value of n, how many values you got for L? That means I have only 1. It implies that the shell is not further divided, right, into subshells. And then is there any further divisions for M? For a given value of L, again you got M value only to be 1, right? So I can simply say from all this, understand that, right? I think if you can recollect in your schools, I think if L value is 0, it is S subshell, and L value is 1, it is P. If it is 2, it is D, and is 3, it is F. That's what you were told. Well, L value is 0, it is S, and 1, it is P, 2, it is D, 3, it is F. If that is the case, in this case, if N value is 1, L value is 0, that is S. There are no further M value is 0, it implies no divisions. In S further, you don't have further divisions in S because the number of values of M is also 0. So what is that basically is, it is nothing but the 1s. Now what is this 1s? It's a combination of an integer number with SPDF. When you have a combination of a number and with SPDF, such combination is called a subshell. Mind you, it is subshell. It's basically subshell. This value of 1 is a shell. If you have only integers given, those are shells. Those integers combined with SPDF are called subshells. And in the subshells you have further divisions, then we call that to be orbitals. That's why in chemistry you don't find further divisions in 1s, because 1s you don't have 1sx, 1sy, 1sz, 1f, etc. You don't find that. You don't find that because for a given value of M, the number of values of L is only 1, not 0. Don't consider the value, the actual value. They have no significance in our chemistry, in our quantum physics. In quantum physics, the values have no significance. It is the number of values what you are giving. So for n is equal to 1, the number of values are only 1. That is, S. And further, the number of values are only 1. So you have no divisions. So it is ridiculous to put on the 1sx, 1xy, 1sz, etc. You must understand that. Right? So if I can write it and acquaint and actually go in for further acquaintance, then I would like to quote this way. Watch carefully now. Watch carefully here. Watch. I can illustrate this in this fashion. Suppose if n is equal to 1, right, then L value is 0 and M value is 0 and S spin can be plus half or minus half. So it's basically n is representing, this is first shell, right? L is 0 is S subshell, because L is 0, you can call it to be S, 1 is P, 2 is D, 3 is F. So if L is 0, it is S. There are no further divisions, no divisions in S. So basically what is this representing is basically 1s. You must understand this. 1s. It's basically 1s. And you are not having 1sx, 1sy, 1sz further divisions because the m values are not suggesting that, right? And you were told s can accommodate 2 electrons and not more than that. Then I think if I can write the quantum numbers in total, quantum numbers, the set is n, l, and s, right? If I can write it, then s can accommodate 2 electrons, the first electron and the second electron. If I can write it, it belongs to the first shell, n value is 1, l value is 0, m value will be 0. The electron can have a plus half, that is 1 electron. The other electron, if I can write it, then it is 1, 0, 0 minus half. You must write electron, that's the other electron. This is nothing but the electron, that is but the electron, and both are present in 1s subshell. You must understand. So I'm very clear in what I'm telling. If you see integers, those are nothing but shells. If you find integers, those are nothing but what? Shells. These integers combined with SPDF are nothing but what? Subshells. You must understand this, right? If this is the case, watch carefully here. So what is this basically? You see, I have an identity. You have so much population, billions of people, well, each have their own identity. If someone is calling me with my name, I raise my hand. In your class, your teacher is calling your attendance, then I think you raise your hand because you have your own identity. Let me tell you, you have billions of people on this earth. And let me also tell you that each DNA is different from the other. So each have their own identity, in spite of having billions of people. Similarly, you tell me any number of electrons, n number of electrons you can tell me, right? Each have their own identity and name. But the names are not like my name being Chandrasekhar, the other fellow might be a Naresh, the other might be a Suresh, or something like that. Similarly, the electrons are also having names. And the names of the electrons are in the form of not Naresh, Suresh, or Chandrasekhar, but understand that they have quantum numbers. This is the name of the electron. Well, I would like to call this is the name of electron. Mind you, this is the name of electron. Mind you, that's the name of electron. And total number of electrons in 1s is 2. Then this is the name of the electron 100 plus half. And the other electron's name is 100 minus half. And the names of the electrons are nothing but this quantum numbers. This I can call this to be name of electron. Mind you that. The name of the electron. One spinning clockwise, the other spinning what? Anti-clockwise. Those are the names. And then we can practice it off like this. Watch carefully here. If I can further practice it for you, watch carefully. Watch carefully, this is how it is. If n value is 2, that means now we are stepping into the second shell. N value is 2. Then I think L values, then it implies L values can be 0, 1 because L values vary from 0 to n minus 1. So if you substitute n is equal to 2 here, it is 0 to 2 minus 1. So it is 0 to 2 minus 1 is 0, 1. It is as simple as that. So L value is 0 and 1. Now what do you mean by this? This is basically the second shell. And L value is basically what? If L value is 0, we call this to be S. If L value is 1, we call this to be P. But S and P both belong to what? The second shell. So I can put the coefficient to be 2S and 2P. And these represents now subshells. And I'm telling you an integer combination with SPDF block, SPDF, I think those combinations are called what? Subshells, you must understand. So what I will do, I'll cherry pick one, this and this for you. So if n value is 2 and if L value is 0, let us take one value at a time. One value at a time. If n is 2, L is 0. If L is 0, M value will be 0 because M value depends on minus L to plus L including 0. So M value is 0 and the spin can be plus half or minus half. So if I can write what are the electrons in this 2s, because L value is S, 0 means it is S. I am taking this 2s out because L value is 0 is S. So I am taking the total number of electrons in S, that is nothing but 2. And if I can write it, and that means that it is 2s has 2 electrons. And if I can write the electron's name, it is basically belonging to the second shell 200 plus half, and the electron's name is 200 minus half. So for a given value of 2, that is the second subshell, you have L value 0. I have taken it outside. When you take it outside, L value is 0, is S. So 2s, it's basically 2s. And the 2s will be having 2 electrons. And one electron name is 200 plus half. The other electron name is 200 minus half. So I have 2 electrons at a stretch, right? So these are nothing but the names. And these are nothing but the names you must understand. Right? If I can take 2 and L value to be 1, and this is how it works it out. Watch carefully. Watch. So if I can take this N value is 2, now I am consider L value 1. You need to consider 1 at a time. This is finished. That is finished because that is 2s. You have 2 electrons. I have named it. Right? And then take the other one. If N value is 2, L value is 1. Right? And if you substitute L value 1, the M values will be minus L to plus L including 0. So it is minus 1, 0 and plus 1. Now if you see the M values, it is minus 1 to plus 1 including 0. So total number of values are 3 values. Don't get into the values. It is the number of values which matter in quantum physics. You must understand that. It is not the values which matter, it is the number of values which matter, and the spin will be plus half and minus half. And L value is P, right? So if it is P and it is second shell, it is 2P. Right? So in the 2P subshell, this is the 2P, which is the subshell. Well, the P can accommodate 6 electrons. P can accommodate 6 electrons, maximum. And each one can be written a name. And if it is accommodating 6 electrons, 1, 2, 3, 4, 5, and 6, I think I can make sets with each and every one, and all belonging to the second shell. So what I will do, and the set is nothing but the quantum number set, NLMS. So I think I can say this electron's name to be 2, L value 1, and take one value at a time. One value at a time, please. One value. So it is 2, 1, minus 1, this is finished now. Take one spin, plus half. At the same time, you can take the same values, minus 1, but change it, minus half. So 2 electrons are finished. Or otherwise I can write it down because I think I have written 6 electrons here. And this electron's name can be 2, 1 and minus 1. This time it is minus half. So this is finished. Now take the other value. Now again start from what? 2. Right, L value will be 1, that is p orbital because it's 2p. Now take this, 0, 0 and plus half, and the other one would be 2, 1, 0 and minus half, right? So this is finished. Now consider this. Now if you consider this, then the electron will be 2, it will be same 1, and then plus 1, and this is plus half, and this will be 2, 1, plus 1 and minus half. You can actually see this is 1, 2, 3, 4, 5 and 6 electrons, and all the 6 electron names I have written. So you must understand that, right? Right? So to distinguish, remember that if you are just putting values 1, 2, 3, 4, those are called shells. Those are called shells. If these are mixed with S, P, D, F, then those are called subshells. You must understand this, right? So in today's class, I was very clear. I was actually discussing the Schrodinger's wave equation, and I introduced the probability concept for you. In the next class, let us see some rules and regulations which we need to follow, because if I give you 100 electrons and ask you to throw it inside the atom, you're not throwing it randomly. What is very strange is, even though the atom is invisible to us, there is absolutely regular arrangement inside the atom. And why there is a regular arrangement? Is there a scheme? Is there a rule which is followed, which we would like to investigate in the next classes? You must understand this. Thank you very much.